Welcome to an introduction to AI safety, ethics, and society. In this final lecture, we'll discuss governance. We'll start out by talking about the relevant actors in AI development and tools that can be used to govern AI. Then we'll discuss briefly AI's impact on economic growth because it's a very important governance topic. Then we'll discuss the distribution of the costs and benefits of AI. We'll discuss the distribution of access to AI, and we'll discuss the distribution of power of different AI systems. Then we'll move to corporate governance, and then national governance, and then international governance, and what are governance interventions that can be done at each level of organization. And then finally, we'll discuss compute governance, which is a promising form of governance for enabling international coordination. So to start out, we'll discuss the landscape and then talk about AI's impact on growth. Some of the main actors in AI development are various companies. They develop and deploy AIs, and they typically seek profits. So some examples of companies include OpenAI, xAI, Anthropic, Meta, and Google DeepMind. At the time of recording, they are all approximately tied in terms of their models' capabilities. Outside of these major AI developers, there could emerge other relevant companies, such as companies that insure individual AI agents. AI agents may in the future get into contracts or potentially do very harmful things. It's hard for chatbots to be extremely harmful currently, but maybe AI agents submitting financial documents on behalf of an individual could cause a lot of harm when they mess up. And AI companies may not want to be liable for their agents' actions, so maybe an insurance agency will absorb some of that legal risk. Other relevant actors in this space include nonprofits and civil society. They may conduct technical or empirical machine learning safety research. They may try to facilitate collaborations. They may try to disseminate information about AIs, etc. And so this organization, the Center for AI Safety, is, doing one of these things by creating this course. There are other organizations such as the Future of Life Institute and MIRI. There's the World Economic Forum, and there's also RAND, which is a think tank that's been focusing more recently on AI topics. And there could potentially be future nonprofits and civil society organizations. A future nonprofit could include a nonprofit that gives IDs or registers individual AI agents so that reputation can be attached to different AI systems, and so that it's easier to keep track of who one is interacting with. National governments can also influence the development and deployment of AIs. And national governments have organizations inside of them, such as the UK's UK AI Safety Institute, or in the US, the Bureau of Industry and Security is a highly relevant organization. The Bureau of Industry and Security, or BIS, is in charge of export controls and affects the flow of GPUs. Continuing onward with the landscape of actors, there are also international alliances, and these can help coordinate efforts between different countries. So there's NATO, there's the G20, which includes China, whereas G7 does not include China. There's Five Eyes, which is an intelligence alliance. There's also the European Union and the United Nations, which includes many more countries than all the rest of these. And as a consequence of its size and given how many stakeholders it has, it generally is slower, though, than these other alliances. There are also individuals influencing AI. For example, there's Elon Musk, there's Sam Altman, there are the Turing Award winners, Hinton and Bengio and LeCun. Hinton and Bengio are quite concerned about AI risks. LeCun thinks that advanced AI is very far away, so there's nothing to worry about. And then there are other actors who were influential in starting to make people be concerned about AI risks, such as Eliezer Yudkowsky. Now, there are various tools in the governance landscape as well, such as information. Information affects how people think and make decisions. So one way to make AI go better is to improve people's understanding of the situation by raising various considerations and facilitating dialogues. There's other ways that information can be helpful, which is just having awareness of what's going on. A government could, for instance, maintain an AI chip registry and know who owns a particular GPU, high-end GPU. We're not talking about, GPUs people game with, but these GPUs that cost $30,000 plus. The government could also query companies in the United States with the Defense Production Act to give them the results of tests that they're running so that the government can be aware of how quickly AI is developing before the products are released to the mass market. Other tools include financial incentives and disincentives, such as taxes and liabilities. There could be export controls, which could limit the diffusion of a technology, such as GPUs. There could also be an incentive, which would be an advanced market commitment from the Bureau of Industry and Security, which could say that if you add these security features to your chips, then you can sell in this market. Other ways of creating financial incentives and disincentives could be government procurement contracts. So in government contracts, they may say, for us to contract with you, you will need to have this level of security for your servers. For instance, they may say that you need to be able to support top secret SCI levels of security. And this would exclude many people providing cloud compute or organizations providing cloud compute, including Google. But Azure, Amazon, and Oracle could get those sorts of contracts. In the future, they could also say, you have to test your models for these various risks for us to contract with you. And even though that is not a legal requirement to get the government contract, they may need to do that testing. There is also standards which set expectations for behavior. They are not binding, while regulations and laws directly enforce behavior. So NIST and ISO and others develop standards. Standards often evolve into laws, or some parts of standards often evolve into laws. Standards also end up flowing into government procurement contracts. State legislatures and US Congress set laws. Now let's speak about growth. How will AI impact economic growth? A common idea is that AI could increase economic growth dramatically, potentially doubling global output every few years, some speculate. Some believe this because there would be potentially an explosion in the effective economic population. So if we have very advanced AI systems, then you could double your population size simply by increasing the number of AIs that you're running by 2. And that's not necessarily the most difficult up to a point. So the effective number of workers could increase maybe by an order of magnitude or more. The number of high-skilled laborers could also increase by several orders of magnitude. And this would reduce a major bottleneck in productivity and in the economy. There would be a large growth in number of AIs as well as in their capabilities. And this could dramatically speed up the economy. I mean, just one very simple point is that GPUs is feed-forward speed, so the speed that it takes before they can output a single token. That speed increases about 30% every year. So if the workers are getting faster 30% every year, then over a few years, that can be very dramatic. Imagine humans getting faster 30% every year. However, there are many potential bottlenecks on AI automation. There are physical constraints. There's only so much energy to go around. And at some point, large AI clusters could strain the power grid. There may also be regulations, such as that humans need to be in the loop, and this could bottleneck AI automation. It may also be the case that scientific research and development does not benefit from many more workers because the low-hanging fruit has already been taken. So even if we have many more smart AI systems, it may not actually move the needle that much on scientific research and development in various fields. There are also bottlenecks from non-automated tasks. For instance, shipping between point A to point B may still take a similar amount of time, and manufacturing of complicated objects such as GPUs may still take many, many years. And so these physical world bottlenecks could also slow down economic growth. There's also cost disease. Non-automated jobs may experience rising costs, counteracting the overall economic impact. And in general, technology just takes a while to diffuse, even if it's a really good idea or even if it provides a lot of utility. For example, electricity took a long time to diffuse throughout society, despite it providing a lot of benefits. So to recap, There are many relevant actors who can influence the development of AI. There are companies and nonprofits and governments and international organizations and individuals. There are many governance tools such as information querying and dissemination. There are standards, regulations, and laws, and there are also financial incentives and disincentives. And AI-driven automation might lead to explosive economic growth depending on how many of those bottlenecks arise and restrict that economic impact. Now let's speak about the distribution of AIs. What's the distribution of control and of access to AIs, and who is getting the costs and the benefits from AI systems? And then we'll speak about corporate governance. How will AI power, access, and costs and benefits be distributed? We'll break this down into three parts. There's the distribution of risks and benefits. Will they be evenly or unevenly shared? Then we'll discuss the distribution of access. Will the AIs be kept in the hands of a small group of people or broadly accessible to the public? And then we'll discuss the distribution of power. Will there only be a few powerful AIs, or will there be many AIs with varying degrees of power? So to start off the discussion of risks and benefits, we're going to discuss automation, because this could greatly affect who is receiving benefits from AI and who is having their livelihood taken away. Is automation going to be good or bad for the general public? Well, in the past, like with the Industrial Revolution, this led to more jobs and a higher standard of living. So if it's similar to the Industrial Revolution, then one might expect that the distribution of benefits will be, somewhat like the past, and there will be a rising tide that lifts all boats. Although it'd be unequally distributed, still the standard of living would increase. However, if we get human-level AI, which is by definition capable of doing every task that a human can do at its level of accuracy or quality or more cheaply, then by definition, there's really no reason to be employing humans for nearly all jobs, unless they're human-specific jobs. So in that situation, one should probably expect unprecedented mass unemployment permanently. A caveat is that maybe wages will go up a bit before they would crash, because maybe AIs can automate 99% of tasks in a job, but this would make humans very productive for some while before AIs automate everything. So humans may then lose their source of income as well as possibly some of their source of meaning. And this would create an unequal distribution of benefits, as people who own supercomputers would reap the benefits of automating labor, and those who don't own that capital end up losing their source of livelihood and their bargaining power. So that's a way in which automation and AI can greatly affect the distribution of benefits and risks. Now let's speak about the levels of access and distribution of access of AI systems. So we'll discuss three levels. There's private AI models, and these can only be used by a small set of people. Private companies and governments in particular may have restricted models, and if they have access to these restricted models, this could lead to single points of failure and risks of a concentration of power, and in a very extreme way, potentially locking in their power and their value systems. On the other end of the spectrum, there are open weight models, and these would be freely available to the public. These models can be edited. The weights of them can also be read. So there's read and write permissions for these, unlike the private models. And these models have less of a risk of a concentration of power. Instead, you end up trading that off for risks of various forms of malicious use. And then there's structured access, which strikes a balance, quote unquote, where the public can access the AIs, but with some restrictions. An example of structured access would be application programming interfaces, or APIs. People can go to the ChatGPT site. They can't see the weights of the model, but they can nonetheless interact with it. Know your customer regimes could enable more intricate forms of structured access. So for instance, with a know your customer regime, maybe AIs with more dangerous biological weaponization capabilities could be given to people who are researchers in biology, but normal customers don't have access to AIs with that advanced virology knowledge of reverse genetics and topics like that. Traditionally, the norm in academe is for research to be openly shared, but there are exceptions. For instance, the Manhattan Project was conducted in secrecy to avoid nuclear secrets from leaking to enemies, and there is still restricted data about nuclear weapons. So while powerful AIs can be used for good, they can also be used with malicious intent. And so this adds a question of whether openness in AI is necessarily a good thing when they are sufficiently powerful. In the short term, right now, AIs don't pose any of those very substantial risks. And so I think it makes sense to err on the side of releasing weights of AI systems. But if they are shown to be able to have the knowledge of expert level virologists and increase the ability of random people to develop bioweapons, then a different cost benefit analysis has to be brought to bear. Releasing model weights is a form of irreversible proliferation. So if there are various unexpected consequences or potential ways in which AIs could be used as weapons, then there's no takebacks with releasing model weights openly. That is not the case with structured access, however. So one should be cautious, especially when AI systems are more capable, before making the weights openly released. They should be tested to see if they carry some substantial malicious use risks. It should also be said, though, that delaying the release of some of those AI systems and restricting their access does have downsides, like it also slows down beneficial research, including AI safety research. So generally, these governance questions come with varying trade-offs. And so to resolve them, a discussion about the costs and benefits with various stakeholders, I think, is necessary. So to summarize, the risks from open weight models is bottom-up malicious use. Rogue individuals and non-state actors could use them to create biological and chemical weapons, maybe radiological. They could also use them to conduct cyber attacks on critical infrastructure, such as the power grid. And there's an increased risk of tail events, and these tail events may be irreversible because there's no takebacks. It's impossible to put the genie back in the bottle. Meanwhile, if it's a controlled model or available through structured access, that has more reversibility. At the same time, then one runs the risk of a concentration of power and people using AI systems to monitor and surveil and extensively enforce existing laws. Many laws are written with the assumption of imperfect enforcement, but AIs could, without any changes to the law, if they empower the government, could potentially make the government be possibly, say, an order of magnitude more powerful. I think an interesting research project could be to analyze ways in which the government could be a lot more powerful with existing laws if they were extensively using AI systems to push their legally determined powers to the limit. Now let's discuss the distribution of power. First, we'll discuss AI singletons. So a singleton is a concept of an AI with a decisive and lasting power over the world. So it's almost nigh omnipotent. An AI singleton is made more likely if AI companies are monopolies and face little competition, if AI undergoes a fast takeoff, that is, it goes from a moderately smart model to a super intelligence extremely quickly. It's worth noting, though, that a fast takeoff does not guarantee a singleton. Just because an AI is a super intelligence does not mean that it's a singleton or has a quote unquote decisive strategic advantage. It needs to be even more powerful than a standard super intelligence because those are still quite vulnerable. As we know from elsewhere, that simple structures can take down very complex structures. I mean, humans, for instance, can be killed by viruses and toxins. AIs can also be destroyed by simple adversarial examples. Perhaps computer viruses can also destroy them. Bombs can also destroy data centers. So a relatively simple structure can destroy some very advanced structures. So singleton is assuming not just a super intelligence, but something with extraordinary, completely unforeseen power. It's worth flagging that most of the people in the AI risk discussions back in the day greatly assumed that there would be a singleton and wrote off the idea that there would be multiple different AIs. Let's discuss the costs and benefits of such a situation. So, a benefit is that there'd be a reduction in competitive pressures and the risks from collective action problems. There's no need to coordinate in that situation. However, of course, this would be a single point of failure. And that could allow for a rogue AI or malicious actor to cause a lot of damage and impose their arbitrary will. So, this is risky business, to say the least. However, at the other end, we also have risky business. At the other end of the spectrum is also a risky situation, which is a diverse AI ecosystem. A diverse ecosystem of AIs would have many capable AIs, none of which have decisive or lasting power over the others. One way one could expect this to occur is if there are many economic niches that do not have increasing returns to intelligence, or if the niches saturate with respect to intelligence. So, for instance, text summarization doesn't require using the most advanced AI system. You could make do with a smaller, more efficient AI. And so this could give rise to many different AIs with different capability profiles and different efficiency profiles. There are some benefits from this. There's more stability. Diverse ecosystems are often more stable than ones with concentrated power. For instance, in agriculture and finance and evolutionary biology, diversity has long-term benefits. There's a positive correlation between the number of species in an ecosystem and its resilience. This also helps avoid single points of failure and also helps potentially dampen the effects of some forms of malicious use. For instance, if one AI fails, other AIs could potentially correct the failure of that AI system. And for malicious use, one could have good guy AIs counteract the bad guy AIs, so to speak. And this can provide some checks and balances for many types of malicious use. Exactly how effective it is depends on the type of malicious use. Some forms of malicious use have more of an offensive advantage, and sometimes there is more of a defensive advantage. There are some costs. Multi-agent ecosystems have collective action problems and can lead to selfish traits. Multiple AIs can exhibit collective emergent properties and create feedback loops and cause unanticipated failures. So with singleton, all we need to do is reason about the intent of the AI systems or the intent of the person controlling the AI systems. Now we have to reason about a much higher complex adaptive system. As well, an AI ecosystem does not necessarily get you out of the failure modes that singletons posed. For example, multiple AIs could collude, and this could fail in a way similar to a singleton. Power among AIs may be distributed unequally and plausibly with a Pareto distribution, such that the few most powerful AI systems may end up having about as much power as the rest of the population or more. And so even if we have a diverse AI ecosystem, there still may be a substantial concentration of power, and there still could be risks of collusion from them. So to conclude, AI power could distribute as a singleton or as a diverse ecosystem of AIs, each with different costs and benefits. AI access could range from highly open to highly restricted. Openness entails dangers from rogue individuals. Restrictiveness entails concentration of power and top-down risks from the elites who control those AIs. The risks of AI are likely to be absorbed by the public unless governance measures are taken. If we have human-level AI, then their livelihoods are taken away. The benefits are likely to accrue to big tech companies, but governance can create a more equitable distribution of benefits. Next, we'll discuss corporate governance and then national governance. Corporate governance is about how can corporations be effectively governed? What are ways they can make AI be more safe and beneficial? To zoom out, let's consider some theories of corporate governance. Some subscribe to shareholder theory, which says that a corporation is obligated to maximize value for shareholders or those who own the company. In contrast to this, there's stakeholder theory, which says that corporations should consider the interests of the stakeholders, but also that of employees and customers and partners and broader society. So one is corporation exists to maximize profit, and the other is it should do that, but also consider various other sorts of factors explicitly and not just implicitly or instrumentally. There are different legal structures which give more freedom to abide by shareholder theory or stakeholder theory. So a C Corp must maximize shareholder value. Google and Meta are C Corps. They have a legal obligation, a fiduciary duty to do so. If they pursue benefits to broader society in ways that undermine profits, there are risks to being sued. In the case of Meta, though, given Zuckerberg's high level of control over the organization, the probability of a successful suit or shareholder activism is a lot lower. It's also often difficult to show. So it is often possible for corporations to do things other than just maximize shareholder value. Public benefit corporations can explicitly pursue public benefits. They can directly do things outside of maximizing profits, and they don't need to worry about being sued if they pursue other sorts of goals. So some examples of public benefit corporations include XAI and Anthropic. There are other legal structures for companies, including LLCs. The place of incorporation also matters when talking about AI companies. Many of these companies are incorporated in Delaware because of business-friendly laws, but due to lawfare in Delaware, some are incorporating in other states, such as Nevada. Here's an example legal structure of one of the major AI companies, OpenAI. It has a complicated legal structure in that it has an LLC, it has a capped profit company. It has a nonprofit that sits on top of that. So in short, there's a nonprofit that owns the for-profit. OpenAI was initially a nonprofit, then sought to raise more money, and then created a for-profit under it. The statutes and bylaws are also highly salient when discussing the legal structure of corporations. Companies typically specify a mission statement upon corporation, and the statutes and bylaws can also specify who has power in crucial situations. So here's OpenAI's mission statement. It says that our mission is to ensure that AGI, that is AI systems that are generally smarter than humans, benefits all of humanity. And so depending on how one interprets this, this could mean that OpenAI should race to develop AI as quickly as possible. Others could interpret it to mean that they should slow down. So it can be very ambiguous, but it does allow them to do things other than maximize shareholder profit. All right, now let's discuss the ownership structure. Companies are owned by shareholders generally, who elect a board of directors, who select executives, who in turn manage the company. So they're often angel investors, and then they evolve into a bigger tech company. They fundraise from various other venture capitalists, and then they eventually go public. This isn't always the case, but these shareholders that have been accumulated along the way can engage in shareholder activism to try and force the company to behave in certain ways. In the case of Meta, for instance, Zuckerberg has a substantial amount of control over the company, so there's less concern there. Meanwhile, Google has many different shareholders and can be pushed around somewhat more by their shareholders if they believe that Google is going in the wrong direction. In terms of the ownership structure, there's a board of directors who have the fiduciary duty to act in the best interests of the company, which can vary depending on the mission. The board can set priorities, manage risks, they can select senior management, evaluate and fire the CEO, and can form special committees. Senior management includes the CEO and the CTO and COO, which directly run the company. Boards may want to ensure that senior management care about AI risk. For a sense of differences in senior management at these companies, Meta and XAI have CEOs with much more decisive power. Meta has Zuckerberg, who has high control over the company. XAI is largely owned by Elon. OpenAI and Anthropic are in between. All these places have CEOs, but some have to suck up more to specific investors. So Elon and Zuckerberg don't need to suck up to anybody. Meanwhile, OpenAI might need to enamor various venture capitalists and large companies such as Microsoft. Anthropic is generally more limited compared to Meta and XAI because they need to be in good standing with Amazon and make sure they don't get mad at them, since they're basically dependent on Amazon for their continuation in the farther future. And Google DeepMind has so many corporate constraints that their CEO probably can't expect them to do something substantially surprising because of so many accumulated political constraints and dependence on Google, which has a clearer mandate to just do what makes the most business sense as opposed to do things that are, more beneficial for humanity or safety. Companies have various organizational units such as research teams, people who work on product, people who work on AI safety, people who work on AI policy. And so organizations that have those could potentially secure safer outcomes and set examples for industry self-regulation. Ownership structures can often be customized. There are often different types of shares. There are, preferred and common stock. There are some with voting powers and some without voting powers. An example, unusual ownership structure is OpenAI's capped for profit model, where shareholders receive profits up to a certain threshold, and then further profits go to the OpenAI nonprofit entity. This may be changed, though, such that the cap is removed. To my understanding, the cap was also changed to be exponentially increasing, so that less and less will be going to the nonprofit entity. The nonprofit entity with that money can donate it to various organizations such as the ACLU, for instance. In theory, there are many ways to govern a company. An AI company could designate that under certain conditions, decision-making be transferred to a committee representing broader society. The OpenAI's nonprofit structure, to some extent, tried representing broader society or people without as much of a financial interest in OpenAI. Anthropic's long-term benefit trust also tries to do something like this, but it's fairly indirect and usually just empowers a few individuals to make decisions for broader society, and they themselves are not elected or placed there in any legitimate way. Some conclusions on corporate governance. Corporate governance exists to balance the interests of shareholders and other stakeholders, including society. AI companies may need to consider novel governance structures, such as purpose trusts or capped for profit structures, and organizational units dedicated to societal risks. Corporations generally have incentives to engage in regulatory capture and fight safety legislation. That's just an additional comment about corporations, if they are wanting to help with safety, should possibly avoid their default incentive to fight safety legislation. Now let's discuss national governance. What can national governments do to promote safer AI? What's the role of government? Well, most would agree that governments should enforce contracts and they should help solve collective action problems and make entities internalize their externalities. So in keeping with some of these roles of government, they could more specifically set safety standards, regulate AI, pass laws about AI. They could clarify exactly who is liable for what harms from AI. They could do something like targeted taxation, such as a value-added tax on GPUs. They could, in a more extreme case, push to publicly own some AI systems. This would be beyond, just enforcing contracts and making entities internalize their externalities. So there's a variety of powers available to governments. In addition to those various tools available to national governments, they could also try to improve societal resilience and try to make sure that their country does not fall behind. Now let's briefly speak about standards, regulations, and laws. Standards are formally written suggestions for best practices. They could comment on all aspects of the AI model development cycle. Standards are developed by governments, industry groups, nonprofits, and other organizations. It's usually a very collaborative enterprise, such as the NIST AI Risk Management Framework, which was developed prior to ChatGPT and took a few years. In contrast to standards, regulations and laws are legally binding requirements. Regulatory agencies set regulations and legislative assemblies make laws. Regulatory agencies and lawmakers are often influenced by special interest groups, and regulatory agencies are often under-resourced. Although there are some notable exceptions of government agencies having competent employees who know about AI, such as the UK AI Safety Institute. Another tool available to national governments is legal liability. This determines who has to compensate whom for damages caused by AI, whether due to an accident or misuse. Liability is a way to internalize risk or internalize externalities foisted onto the public, and promotes safety without explicit regulations from a regulatory agency. This tool has limitations. It cannot be used to cover damages from a sufficiently massive catastrophe. For example, if somebody uses AI to develop a bioweapon, and if the company is liable for that, then they may not be able to pay for the damages. Likewise, if there's an extinction event, obviously nobody's going to get sued in that case. So liability is after the fact and can be a good deterrent for many types of harms. but in many cases cannot compensate society for the risks posed by AI systems in some extreme cases. It's also worth mentioning that AI developers already have liability due to background tort law. So they have to exercise reasonable care, which we discussed some lectures ago, which is to say that they need to prevent foreseeable harms onto their customers and to society. But a lot of legal liability is not fully clarified in an AI context, and that is something that legislation can assist with. If legislation doesn't clarify it, then it will be left up to courts, and that process could take many years. Other tools available to the government include taxation and public ownership. So right now, human labor is taxed, such as through income tax, but automated labor is not. And one could interpret this as a tax loophole. This creates strong incentives for automating people. The government could fix this tax loophole. They could tax AIs, they could tax the GPUs that they run on, they could create a value-added tax on compute as well, and they could give this money to people affected by mass automation in the future. Probably the most powerful thing a government could do is public ownership of AIs or of AI companies, similar to public utilities. They could effectively take over AI companies by getting into contracts with some of them using the Defense Production Act and also determining the flow of GPUs so that they could prioritize making sure that their contractors get GPUs before others. So it's within the government's power to essentially nationalize these companies or pick winners and losers in the future. Obviously, such policies are likely to be opposed by private AI developers, but this is just to paint a picture of the variety of possible actions governments may take. Governments can, in addition to those tools, also affect outcomes by improving resilience. Resilience measures could include cybersecurity and biosecurity and AI watchdogs that monitor for dangerous AIs. AIs could be used for improving cybersecurity, and this could make our nation in many senses safer. Although this would have a limited impact on critical infrastructure because critical infrastructure is very slowly patched, but the government could improve societal resilience just by pressuring providers of critical infrastructure to update more frequently. So you don't need AIs to help patch bugs. Instead, the government could just pressure the people running critical infrastructure to update more frequently, and this could improve societal resilience. Governments could also reduce risks from AI-enabled bioweapons by screening more broadly for emerging viruses, such as through metagenomic sequencing and detecting if a new virus is growing exponentially in various different locations in the United States. This could give us an earlier warning that a new virus is afoot and that we need to investigate and act more cautiously. And in the future, AIs could also help crack down on malicious use by using AIs to identify various threats. Governments can also help or influence AI development by making their nation competitive and not fall behind. It's worth mentioning that the US and China are competing over technological development and will likely continue to race on AI development. Some possible approaches to making sure that the US doesn't fall behind. The US, for instance, could try to facilitate international cooperation with China, which we'll discuss later. Or they could use export controls on GPUs to stifle China's AI industry. They could also change immigration policy to maintain a talent advantage. They could also try to prevent high-end model weights from being stolen or hacked by, for instance, China by demanding that their companies have better information security. They could, for instance, say that for us to contract with you in the future, your servers will need to be able to support top secret information, and this would incentivize AI companies to take information security more seriously. Governments could also do other things like strategically deceive. They could give an indication that they may add backdoors into companies' model weights so that if they are stolen by China, then China has models with many backdoors in them that the US could exploit on the battlefield. Intelligence agencies can also provide a view of the state of AIs in other companies and determine a lot of strategically relevant information. So in conclusion, National governments can set standards and regulations and laws. They can create legal liability for AI harms or enhance the liability or at least clarify it earlier. They can also help improve resilience and maintain national competitiveness through measures such as export controls. And now, finally, let's talk about international governance and something which enables international governance, namely compute governance. How can the international community influence AI development to make it more safe and beneficial? Well, international governance has worked for other types of technologies, such as chemical technologies and biological technologies, so the Biological Weapons Convention. For nuclear technologies, there is Atoms for Peace. So there are precedents for doing this. This wasn't necessarily because countries felt very kumbaya and believing that we all can just get along. There are a lot of rational reasons for creating the Biological Weapons Convention, for instance. The Biological Weapons Convention, one could read that as states wanting to preserve their power because there are much lower barriers to creating weapons of mass destruction through bioweapons. And so by creating very strong norms and pressures against developing bioweapons, then they are maintaining their power. So it's worth not reading into these examples as though, some leaders in the world had a heart-to-heart and then their incentives just changed and then they held hands and became friends. And this is what enabled international coordination. Often the challenge is finding something incentive compatible for these various countries to coordinate on. There are stages in international governance. One is agenda setting. The international community needs to recognize that there's a problem and then set it as a priority. Then they need to start to develop policies, and then they need to start to implement it and possibly create an international organization to help implement it. For example, for nuclear security, there's the IAEA. And then there needs to be continual monitoring and evaluation. Some international governance techniques include unilateral commitments, where one country or company pledges that they will use their technology in a certain way or restrict using technology in a certain way. A variant on this is conditional leadership. A leader could say, I'm going to lead and do this, and I'm going to do that for 2 years, and if nobody follows me, then I will stop. This helps resolve collective action problems because there are often chicken and egg problems with collective action problems, that nobody is doing the thing everybody wants, but nobody wants to be the first one and stick their neck out. Conditional leadership makes it so that they don't need to stick their neck out indefinitely, that they just need to stick their neck out for a limited period of time. And if no one follows, then they can return to business as usual. Some example unilateral commitments could be OpenAI's commitment to use 20% of their compute for safety. They can also commit to work with AI safety institutes abroad, such as the UK AI Safety Institute. Another thing that helps enable international governance would be norms and standards. Norms arise from discourse and precedent. These are non-binding, but they shape and align expectations. For example, there's a scientific norm to publish, and this intertwines the US and Chinese AI research community, and this is believed to reduce the prospect of conflict. Supposedly, in the Cold War, discussions between scientists helped reduce tensions. There are also bilateral and multilateral talks. These can help facilitate coordination and enable cooperation. A relevant entity behind bilateral talks would be the Carnegie Endowment for International Peace, which facilitates many dialogues between US and Chinese individuals. There are also summits and forums such as the UK AI Safety Summit and France's AI Action Summit. There are also governance organizations such as the UK AI Safety Institute and the EU AI Office. There's also the potential for treaties. There are currently no AI treaties, and getting those treaties would be fairly difficult. It's worth mentioning that a treaty does not mean problem solved. It's important that people trust the treaty will be abided by. So if the US and China sign a treaty, the US and China will not necessarily assume that either party will keep their word. So writing something down on a paper is symbolic and can be as useful as a standard or even more useful than a standard and set expectations, but it is not necessarily binding. So treaties are not a panacea to AI governance. In thinking about international coordination, it's important to ask the following questions. When is the technology defense dominant or offense dominant? Can compliance with international agreements be verified? Is it catastrophic for the international agreement to fail? And can the production of the technology be controlled? I'll speak briefly about AI's offense dominance and defense dominance. AI in some contexts is more offense dominant. In the application to bioweapons, that is more clearly offense dominant. In the case of cybersecurity, there's more of a duality, and potentially in the long run, there could be defense dominance where there's formally verified software and there are very few vulnerabilities. In the context of AI for cyber attacks on critical infrastructure, there is offense dominance because the patches to AI systems are not necessarily received or adopted until many years in the future. The software is updated very slowly, and so it tends to be more of a sitting duck, in which case there's offense dominance. So in the case of attacking Google Chrome, there's more of a duality, but in cyber attacks on critical infrastructure, there is more offense dominance. So it varies. In thinking about AI, I wouldn't think of it just as offense dominance or defense dominance. It depends on the application. Even in cybersecurity, one can argue that there's a balance, but in specific contexts, there can be offense dominance. And in the long run, maybe there would actually be defense dominance. So it can be complicated. Now let's speak about regulating military AIs. With military AIs, there could be non-proliferation plus norms of use, and this could restrict AI development. The Nuclear Non-Proliferation Treaty outlined that non-nuclear powers would not try to develop nuclear weapons, and nuclear powers would share the benefits of nuclear technology. Non-proliferation agreements might not suffice if countries benefit dramatically from the developments of AIs, and norms like mutually assured destruction may not be effective with AIs if AI usage is ubiquitous and the dangers are unknown. The Nuclear Non-Proliferation Treaty, while not signed by all nations or fully effective, set a precedent for global action on major nuclear risks. There are other types of regimes one could imagine for regulating military AIs, such as the verification regime, but this would require inspections or compute security features, which we'll speak about later. Or this could require another norm or another way to reduce some sorts of AI risks is to increase the risks of concentration of power, which would be to have a monopoly or have a government entity contract several of the most influential AI entities, but they carry their own risks. It's also worth mentioning, just as an aside, when discussing international coordination, one needs to think about Taiwan. If one's thinking about the international scene, Taiwan is so relevant because they have TSMC. And a Chinese invasion of Taiwan would likely mean TSMC is operational. Either TSMC gets destroyed or the US does not provide the necessary precursors to complete the fabrication of various GPUs and CPUs. This would cause a major global depression and a multi-year AI slowdown and possibly a great power conflict. The probability below may be an underestimate because if China starts to view AI as extremely relevant for their national competitiveness, and if the United States is pulling ahead, they may want to create a multi-year AI slowdown to slow down the United States and do something they already intended to do, which is invade Taiwan. In conclusion, there are many stages of international governance. There's agenda setting and policy making, implementation, and then finally monitoring. There are many tools such as unilateral action, meetings, forums, international organization, and the creation of norm and standards and binding treaties, hopefully. And there are challenges in controlling what happens with military AIs and even civilian AIs. With civilian AIs, it can be difficult to allow China to stipulate what the US should be doing about their own companies. And let's finally speak about compute security and governance, which is a promising avenue toward international coordination. Let's talk about compute. Recall that compute is short for computational resources or the computation power used for developing and deploying AIs. Governing compute would help govern AIs. We'll discuss properties of compute that make it more governable. And we will talk about why it's more promising than governing other factors of AI. Compute is necessary for the development and deployment of advanced AI systems. Currently, compute is in the form of GPUs and TPUs. Compute is measured in terms of floating operations per second, or in a training run, it's referred to as flops. A floating point operation is a simple mathematical operation, such as addition or multiplication. More compute enables models with more parameters, more neurons, and allows them to train on larger data sets or train for longer, and that gives them better representations. So it's bigger brains with more experiences. The most performant AI models cost hundreds of millions to billions in compute, and this number is exponentially increasing. So AI research aims to reduce the compute requirement in developing AIs through the improvement of algorithms. If that algorithmic efficiency becomes quite pronounced, then compute governance is less effective. If a superintelligence only requires 10K GPUs, then this line of governance will be less effective. At the bottom right, I sprinkled in a figure from a paper which analogizes compute to enriched uranium, where it's a necessary ingredient that can be controlled and monitored and is a precursor to all the hazards and benefits that we get from nuclear technology and, in the case of compute, in AI technology. So compute is very governable. There are three factors that influence the development of AI. There's data, algorithms, and compute. However, data and algorithms are informational. Meanwhile, compute is more governable. We can determine who has access to compute. We can enforce laws regarding compute. Compute is physical, unlike data and algorithms. So it can be rivalrous. It can only be used by one entity at a time and is trackable. Informational objects like data and algorithms do not have this property. This is a picture of a part of the fabrication process of GPUs. These machines are extraordinarily complex. There are only a few of them in the world. I should say there are not many of them in the world, and they are ordered up through the next several years. So these present somewhat of a bottleneck in the compute supply chain. Compute is also quantifiable. We can keep track of how much compute was used in training runs. Compute is also excludable. There are only a few major semiconductors and chip firms. It's also the case that AI companies are constantly upgrading their compute every few years. They will cease to use the chips they spent so much on in the past and get rid of them and buy completely new supercomputers. Last, let's speak about compute security. Compute security is what compute governance rests on. Compute security is more of a technical problem of adding control features onto the chips directly. It's about adding low-level security features, and it's a research and engineering topic. Compute governance is more of a think tank, type of topic where people write, high-level suggestions about what to do about compute. But compute security is more nitty-gritty and intersects with hardware security. Some features in compute security could be offline licensing, where the chip is not operational unless it phones home to get a license to continue operation. So it might need to check in every month and attest that it hasn't been tampered with in various ways. And if everything checks out, then it can continue operation. It could also be location verification. This could be approximate or very precise, but there are many ways to more reliably just get an approximation up to 10 or 100 kilometers. This could let one just know what country is it in. If the chip is in the wrong country, then the offline license may not be approved, and then that creates a geofence. So by default, if it needs to check in every month, and if it isn't in the right place, then it will not get a new license, and then this chip will become dysfunctional. So if it's in North Korea or Iran, for instance, then it wouldn't be functional. And that would be a way of implementing geofencing. You don't need high precision for the location. You just might need to have a sense of which country it's in. And so it doesn't necessarily even need to invade the privacy of where it is exactly. Just what country is it in. Other features that compute security could provide could be training mode and inference mode. So let's say there's a catastrophe, or if the world has said, you know what, we need to just harvest the benefits from AI because we just got AGI. That's enough for now. Let's not get a superintelligence. We don't know what that's going to do. Let's pause. Let's verify that everybody is pausing, and let's force all the chips to just go in inference mode and no longer be used for training. This is something that compute security could potentially enable. So a treaty that would say, hey, world, let's pause. We just got AGI. Let's not build a superintelligence for a while. That, by default, wouldn't be trusted. But with compute security and hardware level mechanisms, then we can have substantially more trust. Compute security could also be useful for estimating the amount of compute used in training and determining whether some thresholds are met and whether AI models need to be inspected and tested for potential hazards. For instance, the Harris AI executive order says that if models are trained using more than 10 to the 26 flop, then they should submit to the government tests for whether AIs help enable random users to develop chemical, biological, radiological, or nuclear weapons. So compute security mechanisms can be privacy preserving, and many of these can be implemented in less than a year at a tamper-evident level. This largely requires government action to force players such as NVIDIA to add some of these features. They already have a lot of the features necessary to enable these specific mechanisms to be on the chips. For instance, NVIDIA chips have trusted execution environments, which can make the development of a lot of these features actually substantially easier. But it is still a political question as to whether this would be demanded of them. This isn't to say that these features would be completely robust. That requires more time, but one could plausibly get evidence of whether the AI chips are tampered with, and that could be useful for a verification regime to determine if some actors are reneging on a treaty. In conclusion, compute is an indispensable part of training and deploying AIs and is more suited to be governed than informational objects such as data and algorithms. Compute is physical, excludable, and quantifiable. Governments have a number of tools to govern compute, and much of compute governance rests on compute security, research, and development. So to recap, corporate governance is a collection of regulatory tools that can be used to guide the direction of AI development by individual firms. They could structure themselves to be public benefit corporations or cap their profits. National governance can enable governments to control the development and deployment of AIs within their borders. They can do this through standards and regulations, and they could try to improve outcomes by improving resilience, such as requiring that organizations operating critical infrastructure update the software much more frequently. International governance brings together countries to create global agreements for how to create and use AIs, or just agreements between some countries, such as G7 countries. One can imagine, for instance, the UK AI Safety Summit has brought together various people in a summit. And compute security may enable a verification regime and facilitate various forms of international coordination, even a pause after we get AGI in which we harvest the benefits from AI, but forestall developing a superintelligence. So to recap in the chapter, the landscape of AI governance includes many relevant actors and tools. An AI might take off in various ways, and that could influence the distribution of AI's power as well. There's our political questions of the distribution of access. Should we have the model weights be open, or should we have structured access? There's also a question of where will the economic benefits from AI go? Will it be distributed to the people who just own the capital underlying the supercomputers, namely the GPUs? Or will there be social safety nets for people displaced by mass automation? We've also discussed compute security and that it's a promising way to govern AI and facilitate international coordination. We also discussed corporate, national, and international governance and identified various tools inside of that to exert pressure to steer AI development in a more safe and beneficial direction. Thank you for listening and following through the lectures all the way till the end.